The topic is the laser scanning of the structure during reconstruction based on building information modeling technology. So the purpose of this work and the motivation was following. So research aims to describe and analyze the possibilities of application of LiDAR scanning to the inspection of buildings and structures. Also, to achieve this goal, the following task should be solved. First is to develop and improve the methodology of the program of experimental research of the structure using a scanner. Next one is to conduct a survey to identify deficiencies in the constructions of the buildings that will be needed, and summarize and analyze the results of the survey and conclude the technical condition of the facility. So the motivation was to determine by the fact that the use of LiDAR scanner in inspection of buildings and structures not been sufficiently studied. Along with the development of the construction industry, the use of the latest technology that help to increase the accuracy and efficiency of surveys, reduce costs, and minimize the use of human resources in the performance of survey is becoming relevant. So, building information modeling can significantly speed up the process of rebuilding also in Ukraine during wartime. So it's a crucial moment for Ukrainian needed our days. And using digital models and integrated data, BIM facilities the efficient planning, coordination, and execution of construction works, which is especially important in conditions of limited resources and time. So a few words about BIM and LiDAR. So building information modeling is a comprehensive process for creating and managing information for construction projects. So LiDAR is an actively optical rangefinder it is in an active sensor system that sends a beam perpendicular to the movement of the scanning device carrier. So BIM, one of the most interesting application of BIM, it is in Shanghai Tower. So information modeling helped to rotate the tower by 120 degrees. As a result, the project also minimized the impact of typhoons on the structure and reduced energy consumption by 21%. So very interesting application. And concerning our research program, it is inspection of the buildings during and after the reconstruction is one of the main methods of technical inspection of the object. So the methodology of surveying with LiDAR scanning, followed by integration into software that can recognize scanned objects, could be divided in several stages. First, it is the preparatory stage. Second, it is inspection of building with a scanner. And the third one, it is data processing and creation of three-dimensional model. So in our research, we conduct actually two different objects. First, in the upper side, it is the building that was reconstructed, and second one, it is the structure that contains defects. Typically, you could see here the crack. So actually, two objects was used to our inspection. So in first and second case, the building and the defect was scanned using iPhone's 13 Pro, which has the LiDAR, and in the first case, for the inspecting and analyzing the building condition, and in the second case is for detection the defects on the walls in the form of cracks. So here's the typical LiDAR's device that could be used for this purpose. So in our case, as I mentioned, was used iPhone LiDAR from iPhone 13. So during the inspection of the buildings, with help of the scanner, Ternopil region, these objects are located in Ternopil region. So the technical condition after reconstruction was determined. So during the survey, the following steps were performed: a live tour of the building, second, walking around the building with a scanner, and third, detection of defects. So here's the process, how this the trajectory of the movement of LiDAR scanner with the start and the finish point. So, so the total length of the building, so with a perimeter of 81 meter, is approximately 95 meter. So the obtained point cloud data is stored in special format that allows further processing. So after the scanning, the result was imported to the Revit program in Autodesk, and the resulting model in the Revit software is a building design with the walls, windows, and doors, and the roof of the building was not included in this 3D model due to the limitation of scanning software. So after this, by analyzing a building condition, using 3D model, you can understand its current state more objectively and accurately. This analysis reveals existing problems and potential risks, which allows to develop effective plans for the future management and maintenance of the building. So this approach provides a complex life cycle of building management based on building information modeling, including all stages from the design to its operation. From the resulting 3D model, a detailed layout of the premises was created using Revit software. So this drawing contains all the necessary technical details and dimensions to allow engineers and architects to obtain the geometrical dimensions of the building and plan further maintenance or reconstruction work. So the second object also was performed by this technology. So the crack was scanned using the polycam application. As a result, we got clear image without blue-red corners, and the depth of the crack also could be estimated with this approach. After that, using 3D scanning software, we can measure the width of the crack in different places and compare the results with the actual measurements. And after that, it could be exported to another program for example, to calculate the residual lifetime of the whole structure. So, general conclusions of the high demand and relevance of using LiDAR scanner for measuring buildings and structures have been revealed. After conducting the research and analyzing the data, we found that LiDAR research has significant advantage over research conducted in the traditional way using simple measurement instruments. Scanning technology is relatively new, and scanners and tools for the operation are constantly being improved by major global developers. So it could be concluded that the use of LiDAR scanners simplifies all types of surveys of buildings and structures, significantly reduce the survey time and reduce risks. So thank you for attention.